Hello, my name is Ryan and I'm a data scientist at Lux Digital. Today I'll be going over an LSTM model that predicts the Core Consumer Price Index. The Core Consumer Price Index, also known as CPI, is a measure of inflation that excludes certain volatile items such as food and energy prices. The reasoning behind this exclusion is that these items can have large and unpredictable swings in price, which can make it difficult to discern underlying trends in inflation. By removing these items, the Core CPI aims to provide a more accurate picture of underlying inflation trends. This model is valuable for economists because it can provide insights into future inflation trends, which can inform monetary policy decisions and economic forecasting. By having a more accurate prediction of inflation, policymakers can make more informed decisions on interest rates and other monetary policy tools to control inflation and stabilize the economy. Additionally, businesses and investors can use these predictions to make more informed decisions on pricing and investment strategies. Overall, this model can play an important role in helping to understand and manage the economy. Here in the first cell, you can see we imported all of our necessary libraries as well as dataset. The data used to train and test the model comes from the St. Louis Fed Federal Reserve economic data. We used historical monthly core CPI data along with data from other relevant features, including unemployment rate, disposable income, personal consumption expenditure, and a few others. Down here, you can take a look into what this dataset contains. The columns will represent the different features in the dataset, with the last one being core CPI, and the rows will represent the time series data. Here you can see we also plot the features as a distribution over time. Most of these features are increasing on a positive trend, as you can see here. The same can be said for core CPI. Additionally, we can also plot all of the distributions for the change over year distributed by quarter, as well as distributed by month. The model is an LSTM neural network, which is a type of recurrent neural network that is able to effectively capture long-term dependencies in time series data. We will be going over a univariate model as well as a multivariate model. The univariate model will use past core CPI data to predict the future. The multivariate model will use additional historical features and data relevant to core CPI in order to predict the future. The method used to train the model is a combination of data preprocessing, model training, and model evaluation. The model is trained using the CPI data with a sliding window of past observations, and the performance is evaluated using mean squared error. Here you can see we split the univariate sequence into different samples, define our train and test datasets, as well as define our model. Down here you can see that after the model is done training, it produces a change over time training versus validation loss graph. You can see there's a lot of spikes here due to the small batch size and small dataset. After training the model, we can use it to evaluate as well as predict future values. For this model, we receive a test score of 0.54 mean squared error and a mean model error of 0.59. When plotting the actuals versus forecasted, we can plot them together on a line graph to compare different values. As you can see here, most of our predicted values fall a little under the actuals, so a bit of an underestimation. However, we are still able to capture some trends in the data. Finally, you can also use this model to predict a future forecast. In this case, we predict December 2022 with a core CPI value of 300.83 and a CPI year-over-year change of 5.64%. For the multivariate model, before we get into training the data, we must also make sure the data is stationary, as well as the relevant features are accounted for. We will use the Granger's causation matrix to make sure the features we are using are actually represented by core CPI and are relevant for our model. Again, we split the data into different sequences, define our inputs and outputs, as well as our train and test datasets. We can define the model down here, as well as see the loss graph of training versus validation. We can see here there are less spikes in the data as the batch sizes are bigger and more features can be accounted for. Again, we can evaluate our model. So this model has a test mean squared error of 6.99 and a mean model error of 1.31. For the multivariate model, we can also plot the actuals versus forecasted. And you can see here that While we are still able to capture the positive trend, we are missing some of the patterns in the multivariate model. We can do a future prediction for December 2022 with the multivariate model, and this model predicts a core CPI value of 300.06 and a CPI year-over-year change of 5.37%. Comparing our results with the consensus forecast of economists, which is around 5.7%, our model performs comparably, predicting between 5 and 6% core CPI year-over-year change. This is on par with what the economics predict. In conclusion, this LSTM model provides a useful tool for economists to predict future inflation trends. However, it's important to keep in mind that the model's predictions are only as good as the data it's trained on and the assumptions made during the pre-processing and training stages. Future work could include incorporating other economic indicators in the model to improve the predictions, as well as adding more historical data to improve the time series results. Thank you.